Assalamu alaikum students to week 3 of class 8th chemistry. My name is Manoj and today we are going to talk about a very important topic, Avogadro's number and mole from textbook page 18 and 19. From the previous knowledge, these is the following terms that you should know to follow along in this topic: element, compound and formula, unit. Now, before talking about mole, I should talk about how do you count particles in daily life. In our daily life, whenever we are counting anything, it depends on what we are counting. And we use a unit depending about the thing we are counting. For example, if you are counting shoes, then we count them in pairs, in which one pair contains 2 shoes. If we are counting something like eggs, then they are counted as dozens, in which 1 dozen means 12 eggs. Or if you are counting paper, paper comes as a ream, where 1 ream contains 500 sheets. Now we can see whatever we are counting, we use appropriate unit to count that thing. Similarly, when you are counting particles in chemistry, we need a proper unit, and the unit for that is mole. Now, before talking about mole as unit for counting particles, you should know what kind of particle you are dealing with. That depends on what kind of substance there is. If you are talking about an element, they are made up of atoms. So, here your particle is atom. If you are talking about a compound, your particles that it is made up of is a molecule. Or if you're talking about an ionic compound, the particle that it is made up of is a formula unit. Remember from the previous slides, these are the same particle known as representative particles. So your particle in chemistry can be an atom, it can be a molecule, or it can be a formula unit. Now whatever your particle is, okay, the unit that you are using is known as a mole. Where what is a mole? It is amount of a substance that contains 6.022 into 10 to the power 23 particles of that substance. That number 6.022 to 10 to the power 23 is known as Avogadro's number, represented by Na, because it was discovered by a scientist named Avogadro. And for different kind of particle, Avogadro number is related to mole in the following way. If you are talking about an element, then 1 mole of that element will contain Avogadro number of atoms of that element. Okay, and if you are talking about a compound, then 1 mole of a compound will contain Avogadro number of molecules of that compound. And if you're talking about a formula unit, then Avogadro number of that formula units will make up 1 mole of an ionic compound, since ionic compound are made up of formula units. For example, if you have 1 mole of carbon, since carbon is an element made up of atoms, so 1 mole of carbon will contain how many carbon atoms? It will contain Avogadro number, or 6.022 into 10 to the power 23 carbon atoms. Similarly, 1 mole of sulfur contains Avogadro number of sulfur atoms, because sulfur is an element made up of atoms. So if you have 1 mole of sulfur, how many sulfur atoms do you actually have? You have Avogadro number, or 6.022 into 10 to the power 23 sulfur atoms. This is what you learn when you study Avogadro number and mole. Similarly, if you have 1 mole of water, so how many water molecules actually do you have? You have Avogadro number of water molecules. And here we are counting molecules because water is a compound made up of water molecules. And similarly, if you have 1 mole of NaCl or salt, how many NaCl formula units does it have? It's Avogadro number of formula units. Now you should know NaCl or table salt, it is the same salt that is used in our homes for cooking. There is a formula used to calculate number of mole, and that formula is written as number of mole is equal to mass divided by molar mass. Number of mole, its unit is mol mole. Mass is written in grams, and molar mass, this terminology is written in gram per mole. Molar mass is mass of 1 mole of a substance. Previously I talked about mole as a way of counting particles. I did not say anything about weighing them or about finding out their mass. Now to relate them to their mass, we introduced a term known as molar mass. Molar mass can be different quantities depending on what kind of substance you are dealing with. Now if your particle is an atom, okay, or if you are dealing with an element, then for atoms we write atomic mass. So in this formula molar mass will be replaced by atomic mass. Similarly, if your particle is a molecule or you are dealing with a compound, then you will write molecular mass for it. And in the formula that is written over there, the term molar mass will be replaced by molecular mass. And if you're dealing with a formula unit, or your particle is a formula unit and you are dealing with an ionic compound, then for ionic compound you write formula mass, and in formula up there you will write formula mass instead of molar mass. And you can see these terms: atomic mass, molecular mass, formula mass. All of these terms have already been discussed in previous lectures. Now, to explain this in examples and to relate molar mass with moles, please follow along in this table. If you have 1 mole of carbon, carbon is an element made up of atoms. So 1 mole of carbon will contain how many carbon atoms? It will contain Avogadro number, or 6.022 into 10 raised to power 23 carbon atoms. And how much will these carbon atoms weigh? I said 1 mole of carbon. I did not say what will be their mass. Their mass will be 12 grams. And coincidentally, carbon's atomic mass is 12 gram per mole. So this is a very important relationship in chemistry, because 1 mole of anything contains Avogadro number of particles. Similarly, if you have 1 mole of sulfur, sulfur is again an element made up of atoms. So 1 mole of sulfur will contain Avogadro number of sulfur atoms, and their mass will be 32 grams. And we can see the molar mass of sulfur is 32 gram per mole. Similarly, if you have 1 mole of water, water is a compound made up of water molecules. 1 mole of water will contain Avogadro number of water molecules, or 6.022 into 10 raised to power 23 water molecules, and their mass will be 18 grams. And because this is 18 grams, why? Because water's molar mass is 18 gram per mole. Molar mass is mass of 1 mole of a substance, and 1 mole of water molecules weigh 18 gram, so their molar mass will be 18 gram per mole. Similarly, 1 mole of sulfur weighed 32 grams, so molar mass 32 gram per mole. And 1 mole of carbon weighed 12 grams, so molar mass will be 12 gram per mole. Another example is 1 mole of carbon dioxide. 1 mole of carbon dioxide, again carbon dioxide is a molecule. 1 mole of carbon dioxide will contain Avogadro number of carbon dioxide molecules. Their mass is 44 grams, so molar mass will be 44 gram per mole. Similarly, for 1 mole of table salt, it's an ionic compound made of formula units. It will contain Avogadro number of NaCl formula units. Its mass comes to be 58.5 grams. So its molar mass will be 58.5 gram per mole. That's all for today's lecture. I hope you understood it. Thank you, and Allah.